So to wrap this up, if I want to graph something like this rational function here, it's useful to be able to tell where the asymptotes are and where the intercepts are. And then that kind of gives me an outline of what the graph should look like. So for example, this one right here, it should have a vertical asymptote at x equals -2, because that would make this equal 0 on the bottom. So x equals -2 would be a vertical asymptote. And then there should be another vertical asymptote at x equals 5, because 5 would make this equal 0. So there should be a vertical asymptote here. And the horizontal asymptote, if I look at the degree of the denominator, it's a degree 2. When I multiply this together, it'll be an x squared minus 3x minus 10. And the numerator has a degree of 1. So if the denominator has a higher degree than the numerator, that means the horizontal asymptote will be y equals 0. So I'll have a horizontal asymptote here at y equals 0. And then the x-intercepts are what will make the function equal 0, which I really just have to look at the top, because if the bottom equals 0, they'll be undefined. So that would be -1. So it's crossing the x-axis at x equals -1. And then the y-intercept is going to happen when x equals 0. So if I put x equals 0 in here, I get 0 plus 1 on the top, which is going to come out to be 1. I get 0 plus 2, which is going to come out to be 2, times 0 minus 5, which is going to come out to be -5. If I multiply all this together, I'm going to get 1 over -10. Okay, so -1/10 is like right there about. Okay, so this kind of gives me an idea of what my graph should look like. And if I turn the graph on, yeah. So the idea is that these asymptotes give you an idea of where your graph is going to be roughly. And so that helps you sketch the graph.